Hello student, welcome to the lecture on periodic table, and after this lecture we will be able to learn the following objectives. Learn about periodic table, learn about group, learn about organizing elements, study Mendeleev's periodic table and Mendeleev's periodic principles, study periodic law and trends and history of the periodic law, learn the classification of the elements, learn the periodic trends in properties, study the basic of the periodic system, study basic properties of metals, common metallic materials, study the basic of an element location on the periodic table, study the properties of non-metal and metalloids, study about classifying the elements, study demerits in Mendeleev's periodic table, study electrons configuration in group, study about transition elements, study about ions and ionization energy. Now let us start the lecture with some historical information about periodic table. Dmitri Mendeleev published the primary periodic table in 1869. He showed that when the elements were ordered according to atomic weight, a pattern resulted where similar properties for elements recurred periodically. Based on the work of physicist Henry Moseley, the periodic table was reorganized on the basis of increasing atomic number rather than on atomic weight. The revised table could be used to predict the properties of elements that had yet to be discovered. Many of these predictions were later substantiated through experimentation. This led to the formulation of the periodic law, which states that the chemical properties of the elements are dependent on their atomic numbers. Elements in the periodic tables are arranged in periods that are the rows and groups which are the columns. Each of the 7 periods is filled sequentially by atomic number. Groups include elements having the same electron configuration in their outer shell, which result in group elements sharing similar chemical properties. The electrons in the outer shell are termed valence electrons. Valence electrons determine the properties and chemical reactivity of the element and participate in chemical bonding. There are 2 sets of groups. The group and elements is the representative elements which have S or P sublevels as their outer orbitals. The group B elements are the non-representative elements which have partly filled D sublevels or partly filled F sublevels. People have known about elements like carbon and gold since ancient time. The elements could not be changed using any chemical method. Each element has a unique number of protons. If we examine samples of iron and silver, we cannot tell how many protons the atoms have. However, you can tell the elements apart because they have different properties. We might notice there are more similarities between iron and silver than between iron and oxygen. Could there be a way to organize the elements so we could tell at a glance which ones had similar properties? The periodic table helps predict some properties of the elements compared to each other. Atom size decreases as we move from left to right across the table and increases as we move down a column. Energy required to remove an electron from an atom increases as we move from left to right and decreases as we move down a column. The ability to form a chemical bond increases as we move from left to right and decreases as we move down a column. Usually elements will have rather similar chemical behavior, or there is an identifiable trend of certain physical properties within a group. The notable exception being the hydrogen atom, which is unique and does not belong to any group. It is common to place it on top of the group, one element. The periodic table is arranged based on atomic numbers. The origin was from Mendeleev, who mistakenly arranged elements by their weights. But the mistake was minor because there are only 3 pairs of elements which were not in the right order. Number 1 is AR and K, number 2 CO and Ni, and number 3 Te, and his contribution was tremendous. Here are some features of the periodic table that you should know. Predicting new elements. After arranging the 63 known elements, there were 3 blank spaces. These spaces were elements that had not yet been discovered, and he was even able to predict these unknown elements, chemicals and physical properties. Division of the periodic table. The periodic table can be broken up into 4 general categories: the metals, non-metals, inert gases, and semi-metals. The periods in the periodic table. The periodic table is organized into horizontal rows called periods. Periods contain a series of different elements. The periodic table contains 7 periods. The number of electron levels: period 1 has 2 elements, period 2 and 3 each have 8 elements, periods 4 and 5 have 18 elements, period 6 has 32 elements, and period 6 and 7 are placed on the table to save space and are known as the lanthanoxide and actinides. The groups in the periodic table. The vertical columns of the periodic table are called groups or families. Groups are also known as families, groups of elements with similar characteristics. Patterns can also be predicted from groups. Examples: each element in each group contains the same number of valence electrons. Every family of elements generally reacts the same with other groups. Reading the periodic table. Every square in the periodic table contains lots of information. It contains 4 pieces of information: an element, atomic number, an element's chemical symbol. This is a representation of an element, consists of 1 or 2 letters. An element's name, an element's atomic mass, atomic number, and chemical symbol. Following are the Mendeleev's periodic principles. The elements, if arranged according to their atomic weights, exhibit an evident periodicity of properties. Elements which are similar as regards their chemical properties have atomic weights which are either of nearly the same value, example platinum, iridium, and osmium, or which increase regularly, example potassium, rubidium, and cesium. The arrangement of the elements or of groups of elements in the order of their atomic weights correspond to their so-called valences as well as to some extent to their distinctive chemical properties, as is apparent among other series in that of lithium, beryllium, barium, carbon, nitrogen, oxygen, and iron. Obviously, boron B and fluorine F are meant. Mendeleev's 1869 paper lists the symbols B and F rather than the names of the elements. The elements which are the most widely diffused have small atomic weights. Magnitude of the atomic weight determines the character of the element, just as the magnitude of the molecule determines the character of a compound body. We must expect the discovery of many yet unknown elements. For example, elements analogous to aluminium and silicon, whose atomic weight would be between 65 and 75. The atomic weight of an element may sometimes be amended by knowledge of those of the contiguous elements. Thus, the atomic weight of tellurium must lie between 123 and 126 and cannot be 128. Certain characteristic properties of the elements can be foretold from their atomic weights. Periodic law in chemistry, the generalization that there is a recurring pattern in the properties of the elements when they are arranged in order of increasing atomic number, that is the total number of protons in the atomic nucleus. Classification of the elements. In 1864, J.A.R. Newlands proposed classifying the elements in the order of increasing atomic weights, the elements being assigned ordinal numbers from unity upward and divided into 7 groups having properties closely related to the first 7 of the elements then known: hydrogen, lithium, beryllium, boron, carbon, nitrogen, and oxygen. This relationship was termed the law of octaves by analogy with the 7 intervals of the musical scale. Then in 1869, as a result of an extensive correlation of the properties and the atomic weights of the elements with special attention to valency, that is the number of single bonds the element can form, Mendeleev proposed a periodic law by which the elements are arranged according to 115 periodic table. The magnitude of atomic weights show a periodic change of properties. Lothar Meyer had independently reached a similar conclusion published after the appearance of Mendeleev's paper. Periodic trends in properties. The elements of group 0 are gases that are difficult to condense. The alkali metals in group 1 are soft, metallic solids with low melting points. The alkaline earth metals in group 2 are harder and have higher melting points than the adjacent alkali metals. the hardness and melting point continue to increase through group 3 and 4 and then decrease through group 5 and 6 and 7. The elements of the long period show a gradual increase in hardness and melting point from the beginning alkali metals to near the center of the period, and then at group 4b an irregular decrease to the halogens and noble gases. The sizes of atoms of elements vary regularly throughout the periodic system. Thus, the effective bonding radius, or one-half the distance between adjacent atoms in the elementary substances in their crystalline or molecular forms, decreases through the first short period from 1.52 atom for lithium to 0.738 atom for fluorine. At the beginning of the second period, the bonding radius rises abruptly to 1.86 atom for sodium and gradually decreases to 0.99 atom for chlorine. The behavior through the long periods is more complex. The bonding radius decreases gradually from 2.31 atom for potassium to a minimum of 1.25 atom for cobalt and nickel, then rises slightly and finally falls to 1.14 atom for bromide. The sizes of atoms are of importance in the determination of coordination number and hence in the composition of compounds. The properties of the atomic nuclei themselves, such as the magnitude of the packing fraction and the power of entering into nuclear reaction, are although dependent upon the atomic number, not dependent in the same periodic way. The basic of the periodic system. Electronic structure. The noble gases helium, neon, argon, krypton, xenon and radon have the striking chemical possession of forming few substance compounds. This property would depend upon their possessing especially stable electronic structures. The Pauli's exclusion principle states that no more than 2 electrons can occupy the same orbit, or in quantum mechanical language, orbital in an atom, and that 2 electrons in the same orbital must be paired. The orbitals in an atom may be described by a principal quantum number n, which may assume the values 1, 2, 3, and by an azimuthal quantum number 1, which may assume the values 0, 1, 2, up to n minus 1. There are 2l plus 1 distinct orbitals for each set of values of n and 1. The most stable orbitals which break the electron closet to the nucleus are those with the smallest values of n and l. The electrons that occupy the orbital with n is equal to l and l is equal to 0 are said to be in the K shell of the electrons. The L, M, N shells correspond respectively to n equal to 2, 3, 4. Each cell except the K shells is divided into subshells corresponding to the values 0, 1, 2, 3 of the orbital quantum number 1. These subshells are called the S, P, D, F subshells, and they can accommodate a maximum of 2, 6, 10, 14 electrons.
The periodic table can be divided into 3 main groups: metals, nonmetals, and metalloids. Metals are malleable, which means they can be beaten into thin sheets. They're ductile, which means they can be made into wire, and they're good conductors of heat and electricity. Nonmetals are brittle and they're poor conductors or insulators, which means they do not conduct heat or electricity very well. And then there's metalloids, which are elements that have some properties of both. When looking at the metalloids, there's only a few of these elements that have these characteristics, and they're located right there, and they almost form what we call a staircase. To the left of the staircase are the metals. Are the metals here, and they're anywhere to the left of the staircase. except for, sorry about that, except for hydrogen. Hydrogen is one of the ones that is not considered a metal. And then you have the non-metals to the right of the staircase. Again, these are brittle, poor conductors of heat and electricity. And don't forget hydrogen there.
Newland's law of octave. In 1866, a British scientist, Newlands, reported the law of octave by arranging elements according to increasing order of their atomic masses. He noticed that every 8 elements starting from any point approximately has similar properties. Newland's arrangement was applicable only to a few elements. After that, it was failed. Laws of traits, de Baronner's traits. In 1829, a German scientist, de Baronner, made use of the relationship between atomic masses and properties of elements. Drawback: this rule is not for all the elements. Luther's Mayer's classification. In 1864, a German chemist, Luther Mayer, published an incomplete periodic table. He included about 56 elements arranged in a group from 1 to 8. He plotted the values of different physical properties and obtained different curves. In these graphs, he observed that elements with similar physical properties occupy similar position in the curve. For example, alkali metals occupy the peak of the curves. Halogen occurs on the ascending portion of the curve. Mendeleev's periodic table offered the following advantages in understanding the properties of elements. There was a regular gradation in physical and chemical properties of elements. The group number of an element indicates highest oxidation state that it can attain. There were many vacant spaces in Mendeleev's periodic table for the elements to be discovered. He named them Eka boron, Eka aluminum, and Eka silicon. He also predicted the properties of these undiscovered elements, including atomic masses. These elements were discovered as Sc, Ga, and Ge with same feature as he predicted. Mendeleev's arrangement helped to correct atomic masses of a number of elements. The demerits in Mendeleev's periodic table are: for placing the elements in proper groups, the order of the elements according to atomic mass was reversed in certain cases. He placed iodine 127 after tellurium 128, potassium 39, and Ni 58 after CO 59, which is against his periodic law but correct according to properties. Mendeleev's periodic table does not provide a clear idea about the structure of atom. Have been assigned places in the periodic table which is against the periodic law. Alkali metal and coin H metals, Cu, Ag, and Au, which differ widely in properties, are placed into the same group. There is no separate position for isotopes in periodic tables. The change in atomic mass of two successive elements is not constant. Hence, it is not possible to predict the number of missing elements by knowing the atomic masses of two known elements.
In 1869, Dmitri Mendeleev could see that properties of elements vary periodically. As atomic number increases, the properties repeat in a soothing rhythmic pattern that can form a funky beat. The elements we know about, they number 114. Some in quantities so small that they've never been seen. Most are common elements that are far and wide dispersed, but all of them together make up all the universe. Elements in group 1 are called the alkalis. They explode in water and are of very tiny size. They love to lose electrons when they form a bond. Of these reactive atoms, I can say I'm rather fond. Group 2 elements are often called alkaline earth. Calcium's been building bones since well before your birth. They form nice +2 ions and are generally quite fun, though they're not quite as reactive as the metals in group 1. Metals in groups 3 through 12 transition elements. Some of them are lightweight and others really dense. Things they have in common, they form charges 2 or more. and some form colored compounds, which is something we adore. If you want an element, just tell me once again. If it's in group 17, you've got a halogen. Nonmetals so corrosive, they're not found in their pure state. They can gain electrons like they're going out of date. Got one for you in group 18, it's known as noble gas. If you're looking for an element that just sits there on its... If you wonder why and haven't figured it out yet, their valence configuration is a big stable octet.
Now in the end, let us summarize what we have learned in this lecture. Dmitry Mendeleev published the primary periodic table in 1869. Elements in the periodic table are arranged in periods, rows and grouped columns. Groups are organized as vertical columns on the periodic table. Periods are organized as horizontal rows on the periodic table. The periodic table can be broken up into 4 general categories: the metals, non-metal, inert gases and semi-metals. Metals have useful properties including strength, ductility, high melting point, thermal and electrical conductivity and toughness. Metals are located on the left side and the middle of the periodic table. Group 1A and Group 2A, the alkali metals are the most active metals. Non-metals on the right side of the periodic table are very different from metals. Their surface is dull and they do not conduct heat and electricity. Elements that have properties of both metals and non-metals are called metalloids. The amount of energy necessary to realize ionization is called ionization energy or ionization potential.